So guys, we had to continue with rotational motion. Two things are important as I told you in yesterday's class, no? That perpendicular axis theorem as well as the parallel axis theorem. We'll start with the perpendicular. See, understand moment of inertia. Yesterday we learned that it is represented by the letter I. Okay. So you write I. Now, this is general formula for this concept. We know that moment of inertia when it comes to linear motion was nothing but mass. You write m and the distance covered with a square on it. Now, we won't have understood the meaning of it because I haven't spoken about the application yet, but this is general formula. So I write I into m into the distance it covers, the square of it. Getting it? I'll take it off because you get confused. Perpendicular axis theorem means it's very simple. Suppose you draw a diagram. Obviously, a diagram which has x-axis, y-axis as well as the z-axis. So you write x, you draw x-axis, y-axis as well as the z-axis. X, so y as well as z. Now, obviously, assume one vector like this, and this vector is going to be r. Draw dotted lines here. Now, what does this mean? That this one of the values is x, one of the values is y. The diagram is completed. Very simple diagram. Now, if you actually observe this, okay, I should have, okay, make sure that this angle is 90 degrees because I'm supposed to apply Pythagoras theorem here. Now, understand perpendicular axis theorem. If you look at the box, it becomes r square is equal to x square plus y square. Got it? Simple. X and y because of the Pythagoras theorem. If this is y, this also will be y. And you apply Pythagoras theorem, you got r square is equal to x square plus y square in this specific right angle triangle. Now, once you find this, I'm supposed to find moment of inertia. Now, this is not yet complete. You should write moment of inertia about x-axis. So I think you got a hint right now. So the perpendicular axis theorem tells us to find the moment of inertia of all the three axes, step by step. First you find for x-axis, then you find for y-axis, then you find for z-axis. So moment of inertia is I. So since it was x-axis, you write Ix is equal to, apply the same logic here. You write summation because summation meaning there are many vectors like this. I'll talk about all the vectors at the same time. That's the meaning of summation. So it says m into, I'll give you a hint. X, okay, x, this distance is parallel to which axis? Parallel to y-axis. Therefore, Ix will be m into y square. It should not be the same is what I'm trying to tell you. If the left-hand side is x, that's the axis. Fine. Now you find x there as a distance. That distance is perpendicular to whom? It is parallel to whom? It is parallel to y. Therefore, you write the answer as y. That is one of the things. And how else remember? Whatever letter is there on the right hand side, that letter should not be on the left hand side. Same concept. So automatically, moment of inertia about y axis will be Iy is equal to summation m into, obviously it should not be y on the right side. What else can be there? X. So you write x. That's all. So this is equation number one, equation number two done. But there's one more axis called as z-axis. Obviously, z you will write, summation symbol m. We are done with all the axes. What is this there? See, x is a vector, y is a vector. R is also a vector. So therefore, you write Iz is equal to m into r square. That's all. That's all. This is the diagram. Getting it? Now, if you see Iz is equal to m into r square, I'll only expand the equation number 3. I'll write Iz is equal to summation of m into, instead of writing r square, based on Pythagoras theorem, I'll be able to write x square plus y square. Correct? So I'll write x square plus y square. Substitution. Now keep the left hand side as it is. Iz is equal to summation as it is, m as it is, multiply m throughout the bracket, sorry. It becomes mx square plus my square. And put a summation symbol for everything. Left hand side, write Iz is, as it is. Summation of mx square is nothing but Iy. You write Iy. This is Ix. Theorem done. I'll repeat. Very easy. You draw three axes, r, x, and y. So applying Pythagoras theorem, you get r square is equal to x square plus y square. Simple. MOI, moment of inertia about x-axis. Ix will be equal to summation of my square, because left hand side, right hand side, it should not be the same. So perpendicular axis theorem. Iy, obviously left hand side, right hand side should not be the same. Summation of mx square. Next is Iz. Iz is equal to summation of mr square. Done. Now we'll expand the third equation. mr square. Instead of writing r square, I'll be able to write x square plus y square. Multiply m throughout the bracket. You get this. These two answers I already know. Get this answer. Simple. It's just like perpendicular axis, there'll be something called as parallel axis theorem. Now, what's the difference? Very simple. Instead of drawing perpendicular lines, draw parallel lines. Okay, straight lines only will draw. Draw two parallel lines, and the distance between them represent it as d. That's all. And place the point outside. Oh, got it? Now, very simple. I is equal to m into distance. Okay, this is r, guys. This side is r. Or okay, wait. This also is r. Fine. This also is r. So if you see the total distance, it's nothing but m into x plus d the whole square. How? You're standing here, or x plus d or r plus d, anything is fine. Whatever you took, let's take it as x itself. So from here to this end, what is it? X plus d the whole square, the total distance. Therefore, right, m is equal to, I is equal to m into x plus d the whole square. Now what you do? M as it is. X plus d the whole square is nothing but a square plus b square plus 2ab. Now what can be done? Left hand side, keep it as I itself, equal to m into multiply m throughout, mx square plus md square plus, okay, summation I forgot. Summation symbol, sigma x square, sigma 2mxd. Got it? Now always understand, this becomes 0. Why? I'll give you a simple hint. If there is no square, 0. That's all. Left hand side, I is equal to summation of mx square plus summation of md square. That's all. Will be asked for 5 marks or 3 marks continuously. There's no explanation only for this. Directly get the answer. This is for parallel. So totally combined 5 marks. These are the most important things in the chapter. Nothing else is there. So to repeat this, you draw two parallel lines, place a point O, x distance to the first line, and x plus d distance to the second line, x plus d, full. Now again, I told m into distance square, m as it is, right? Total distance was x plus d the whole square. Apply a plus b the whole square formula, I got some answer. Sigma m multiply throughout, you'll be able to, you'll get sigma mx square and sigma md square, plus whatever. But the problem is, since it does not have a square here, take it off. Simple. If square is not there, ignore it. That's the hint. Ignore this because square was not there. Both the things have the square. Keep it as it is. Can we simplify this? Need not simplify. That's all. Both of them combined together, 5 marks. Nothing else apart from this will be asked in rotational motion. So what I thought was, once you're done with rotational motion, no, tomorrow's class we'll start solving papers. Today, I want you guys to, solve all these math derivations. Repeat it. I'll tell you what and all to solve. 1 minute, wait. Sandwich theorem video is there on YouTube, which I sent you the other day. Practice that again, because practice that and then come tomorrow's class. I'll be able to do off limits and derivatives. I'll continue with it. It's easy for me to. This is the starting point of it. Bernoulli's principle, if you remember. If you don't know, if you do not have the derivation, I'll send it to you. The YouTube link I've recorded and put it there. Bernoulli's thing. I'll send that. Follow that. Both these theorems, practice and come for tomorrow's class. Along with this 1 minute, this one also. Modulus function and signum function. 3 of them totally. So in math. So today's work is you practice this. What else? This perpendicular axis and parallel axis theorem. Along with the sandwich theorem, Bernoulli as well as modulus and signum function. Don't forget, I'll see you in tomorrow's class. We'll solve the papers tomorrow's class.